Okay, we want to estimate the distance traveled by a car in a 30-second interval. And we're giving the information here. Now, the information we're given is the velocity feet per second of the car, which was measured every 5 seconds. So here's our data set, and here's a graph that goes along with that. We're going to solve this problem 4 different ways, and these 4 methods you need to know for the AP exam. So let's start. The first method is called the left corner method, because what we're going to do here is to determine the distance for each interval, we're going to multiply the velocity times the time. Now, the time is not going to change because there are 5 second intervals all the time, right? 5, 10, 15, 20, and so on. But the velocities will depend on whether we pick the first data point as our velocity or the second data point. If we're picking the first data point as our velocity multiplied by 5, that's going to be the left corner of the rectangle that we draw from here straight across and then straight down. Okay, so that is the left corner of the rectangle, and we multiply the height here, which is going to be 25, by this time interval here, which is 5 seconds. So that's the area of the first rectangle. And we're going to continue this process here. We're going to take this data point as our left corner, draw a rectangle, and we're going to multiply 31 times 5. And moving on, this one here will be our left corner, straight down this time 35 times 5. This one here is 43 times 5 plus the next one here. Right across, straight down. After 43, 47 times 5. And our last rectangle, we're using this data point here as our height, which is 46 times 5. So using a calculator, you should get, or I got, 1,135. You can check my calculation here. What are the units? Well, we're multiplying velocity, which is measured in feet per seconds in this example, multiplied by seconds, we get feet. Okay, method 2, the right corner method. So same process, just that we're going to use the right data point as our height. So we'll draw the rectangle with that height. So the time interval doesn't change. That's still 5, but this time we're going to start with a height of 31. 31 times 5. Plus, let's continue. This will be our right corner. We'll use that height. And that's 35 times 5. Right corner. That's 43 times 5. $47 times 5. Continue down here. 46 times 5. And our last rectangle, right corner is here. That's the 41. Okay, so 41 times 5. And get your calculator out. Okay, so please verify this calculation. I get 1,215 feet. So in this particular case, the right corner method is an upper estimate, which is greater than 1135. That's the left corner method. Okay, method 3, the trapezoidal method. So now we're going to split up our regions into trapezoids. So if we were to connect this point to that point with a straight line and then come straight down here, this shape is a trapezoid. So we're going to calculate the area of this trapezoid. So let's go back and recall this. The area formula for a trapezoid is the height. Now, when I say height, I mean the distance between the two parallel sides. So in this case, it's 5, and it's going to be 5 for each of the trapezoids we draw. So it would be 5 divided by 2 multiplied by the length of the two parallel sides. So this length and this length, we got to add those, and then we can multiply by the h divided by 2. So the formula looks something like this. Okay, so we're going to do this. Our height, as I mentioned, is this distance here, which is going to be 5 seconds every time. So 5 divided by 2, you may want to change that to 2.5. And A plus B, this side length here is 25 and B is 31. So you just get that from your data set here. 25 plus 31. Moving on to the next trapezoid. Connect the dots. Straight line, straight down. Again, we have 5 divided by 2. But this time, we'll use this side length here and this side length here, 31 and 35. 31 plus 35. Plus the next trapezoid. Connect the dots. Straight down. 5 over 2. And then the next pair would be the 35 and the 43. So 35 plus 43. Continuing here, the next trapezoid, connect the dots. 5 divided by 2. And this time we'll have the 43 and the 47. 43 plus 47 plus, continue, trapezoid here, 43 and 47. So the next one will be 47 and 46. We'll use those numbers. So 5 halves of 47 plus 46. And our last trapezoid, we'll use the last data points here, 46 and 41. 46 plus 41. So get out your calculators, perform this calculation. Like I said, you may want to change this to 2.5. That may simplify things. Okay, I get 1,175 feet. So one thing I want to say here is this number is between the left corner estimate and the right corner estimate of the previous slide. The numbers were 1,215, 2,350. If you were to add those two estimates and divide by 2, in other words, calculate the mean or the average of those two, you'll get exactly this number here. So I went through the calculation in the drawings, but if you already did your left corner method and your right corner method, and you had those two numbers, you could just take the average and you will get this number right here from the trapezoid method. Okay, the last method, the midpoint method here. And we're only going to use 3 rectangles here, and I'll show you why. Because we're going to divide this interval from 0 to 30 into only 3 rectangles. That means each one is going to be a 10-second interval. And we're going to use the data point in between for the height. So this one here is between these two. We'll use that as our height for the rectangle. And so we'll use that straight across and then straight down. So because it's a larger rectangle, see this time interval is not 5 anymore, it's actually 10. Okay, and we're going to use this midpoint as our height. So going up to our data set, that's going to be the 31. So here we go. We're going to use 31 multiplied by 10. That's the first rectangle. The second interval, the second 10-second interval from here to here, we're going to use this data point, this midpoint, and we're going to draw a rectangle here, like so. So this data point here, uh, is 43, or the velocity is 43. So 43 multiplied by, again, 10. It's a 10-second interval here. And then we have our last rectangle. Use this as our height. So draw a rectangle with that being the height. And then that will be our last 10-second interval here. So we have three rectangles with equal time intervals of 10 seconds. And this data point here, that velocity is the 46. So 46 times 10. So get out your calculators. Okay, so I get 1,200 feet. Again, that's pretty close to the trapezoid method. So there you have it, the four methods, the left corner, right corner, trapezoid, and midpoint method. You need to be familiar with all four methods because AP exams always have, they'll always ask you to use one of these methods in solving a problem with a set of values.